Okay, so welcome. In this screencast, we take a look at the last transformation we're going to look at, dilations. You have surely done dilations before. You take some figure, looks like this, and you have some point that is the center of the dilation. Let's move that point over to here. And you have some, and let's move the figure over to here, just because it'll be easier in the diagram. So you have some figure, and it looks like this, and you have some point that's the center of the dilation. And then what we want to do is we want to dilate with P as the center, and we want a scale factor of 2. Well, what does that mean, scale factor of 2? Well, that means that there's some line through P and A, and we want this distance to be multiplied by 2 to reach A prime. So whatever PA is, we go twice as far, and that's A prime. So whatever, here's line PB, whatever distance PB is, we want to go twice as far, and that's B prime. Whatever, here's line PC, whatever distance PC is, we want to go twice as far, and that's C prime. That's a dilation. Now, what effect does that have? Well, the effect that that has is that whatever this length is, that length is twice as big. Its corresponding length is twice as big. But you'll notice that the angles all remain the same from the little figure to the big figure, from the pre-image to the image. In fact, triangle A prime, B prime, C prime is similar to triangle ABC. And the ratio of the side lengths is this number 2. So a couple of things I have to point out because they may not have been crystal clear in the reading. We always name a center for our dilation. Every dilation has a center. That's important. And every dilation has a scale factor. That is also important. And that scale factor tells us the ratio of the sides, image to pre-image. Image over pre-image gives you the scale factor. So what's important to remember here is that when you do a dilation, what you get every time is a similar figure. So if we have some point P and we have this thing here and we want to do a dilation maybe with a scale factor of 3, well, we would pick this point right here, and then so we pick this point right here, and then whatever this distance is, we go 1, 2, 3, and that's the image. So if that's point A, that's point A prime, and then maybe we do that with this point over here, maybe. Whatever this distance is from P to B, we go that and again, and that's B prime. And then maybe we pick some point up at the top here, maybe that's point C, and we have line PC, and whatever this distance is, we do that and again, and that's point C prime, and we get a figure that is similar to the original figure, but 3 times as big in all its linear dimensions. It's its base is 3 times as big as the base of the original figure. This arc is 3 times as long as the corresponding arc on the original figure. This is how dilations work. Now we could do these dilations on the coordinate grid. Let's see. We could. Yeah, so if we do this on the XY grid, usually we make the point P the origin, because that's easier. And then you got some triangle like this. This will be triangle BIG, where this is 1, 2, and this is 1, 1, and this is 3, 1. And let's say we want the scale factor to be 2. Well, what would that do? Well, we go to the I and then just as far. We go to the B and then just as far. We go to the G and then just as far. Nope, that's the wrong trajectory, right? I made a little turn to the G, then just as far, right? If you go 3 over and 1 up, you got to go another 3 over and another 1 up, and you get a figure that is similar to the original figure, and the side lengths are twice as big. Notice what happened to all of the coordinates going from triangle BIG to triangle B prime I prime G prime. Dilations preserve the shape because they hold similarity, right? They keep similarity happening, so the shape has to hold. The angles all hold. The side lengths don't hold. Dilations are not isometries. They are not congruence relations. They are similarity transformations. Orientation is preserved in a dilation as long as the scale factor is a positive number, and I really don't know what it means to have a scale factor be a negative number, although some people do talk about negative dilations, and what they mean is that they do a half turn and then a dilation, but that's neither here nor there. This is how dilations are done on the coordinate grid. So we have how to do a dilation off the coordinate grid and how to do a dilation on the coordinate grid. In all cases, you get similarity. Triangle BIG is similar to triangle B prime I prime G prime. And in all cases, angles are preserved, orientation is preserved, but side length is not. And those are important things for you to know as we close up our study on transformations.